Good morning, everyone. All of you can hear my voice. Please confirm in the chat box. Perfect. Yeah. Happy Independence Day, guys. Today is August 15th. Happy Independence Day, everyone. Good. Can you see my screen now? Can you see my screen now? Perfect. Guys, in the last session, we discussed about what is microservices. What is microservices? What is microservices architecture? What is API gateway? What is service registry? What is admin server, what is a Jipkin server, what is welcome API and greet API. And we are able to develop one mini project also by using all these components. Eureka server, we are using as a service registry. Using that, we can register all our backend services at one place so that we can easily understand how many services are there, what are the names of the services, what are the URLs of the services, and what is the status of each service. We can get it from service registry. Next one, admin server. Admin server provided by CodeCentric. It is used to monitor and manage all the services at one place. The next one, Jipkin server is available. The next one is a Jipkin server. Jipkin server is used for log tracing. Jipkin server is used for log tracing, right? And the next one, backend APIs are available. So we can develop multiple backend APIs for our business logic. And one API can connect with another API, depends on the business requirement. If one API connecting with another API, then that is called as inter-service communication. Inter-service communication. So to achieve that inter-service communication, we are using FIAN client. Perfect. Depends on the requirement. Our backend APIs may communicate with third-party APIs also. Next, microservices architecture. In that we have API gateway. So what is this API gateway? API gateway will act as a front gate for all the APIs in the backend. So there are so many APIs in the backend. We are not going to provide the direct API access for the public. We are not going to provide direct API access for the public because that is not secured. So that's why we will use one API gateway. API gateway will act as entry point for all the backend APIs. API gateway will act as entry point for all the backend APIs. Our API gateway contains filters and routing. Filter is used to perform some pre-processing and post-processing request, whereas routing will decide which request should go to which API. Routing will decide which request should go to which API. So yesterday we created our mini project. Service registry we created, admin server we created, welcome API we created, greet API created, API gateway also we have created. In the API gateway, we have this configuration in the YML routings. So if a path is /welcome, then that request should go to welcome API. This is one of the routing in the API gateway. If a path is /greet, that request should go to greet API. This is one of the routing in the API gateway. Fine. Then what about filter? Now I want to write a filter. So that filter you can use to get the request information, and you can do some monitoring logic we can write, or you can write some logic to secure and to validate your request also. Such kind of things can be done by using filter. Okay, now how we are going to create a filter? So let us see how to create a filter in our API gateway. Here, let me create one filter, new class, my filter, new class, my filter. You can give any name for that, my pre-filter. I'm creating a filter. I'm creating a filter now. So to represent this as a Spring Bean, I will use one annotation called @component. So whatever the filter I'm creating, that filter should be considered as a Spring Bean. Whatever the filter I'm creating, that filter should be considered as a Spring Bean. For that, I'm using one annotation called @component. @component. Okay, the next one. I'm going to write one method. For that, I'm going to implement global filter. To make this class as a filter, I need to implement one interface called global filter. So where that global filter is available in the cloud gateway, we are having that global filter now. So when we override, when we extend that, when we implement that interface, we need to override a method called filter method. We need to override a method called filter method. Public class my pre-filter implements global filter. Public mono void filter. This is the method I am trying to override. This is the method I'm trying to override. Public class my pre-filter implements global filter. Okay, so public mono of filter, server web exchange, gateway filter chain. I'm getting this. Inside this, we can write our logic. Inside this, we can write our logic. So fine, if you want, I can add some logger for this. Logger is equal to logger factory dot get logger. For this pre-filter, I'm getting one logger object to write some log messages. For this, I'm using logger. Logger dot get logger factory dot get logger of my pre-filter. Okay, inside this, I can write some data. Logger dot info. I will just specify that filter method execution started. Filter method execution started. So this is one of the method. Okay, filter method execution started or filter method executed. Filter method executed. Now inside this filter, you can access request information. Access request information. How can we access that request information now? How can we access that request information now? Here already we have a server web exchange parameter. Na exchange is available. Exchange dot get request. Exchange dot get request. So we are having this request object. So which will give server HTTP request. So whatever the request coming from the client to our API gateway. So clients are sending a request to our microservices application. Clients are not going to access backend APIs directly. Clients will be sending a request to API gateway. Clients will be sending the request to API gateway. So whatever the request coming from clients to the API gateway, I want to access that request. For that, I'm using exchange dot get request. I got the request data. Once we got the request data, so now using this request, using this request dot get query parameters, get path parameters, get body, get headers. Once you have the request object, can you access all the request information sending by the client? Whatever the header data they are sending, whatever the payload data they are sending, whatever the header, whatever the payload, whatever the header they are sending, whatever the payload they are sending, can we take that? Can we take that information? Can we access that information from the request object now? Any headers that they are sending in the request, any path parameters they are sending in the request, any query parameters they are sending in the request, any payload data they are sending in the request. Can we have the access for complete client request in the API gateway? Come on, guys. Do you have the access for the complete request given by the client? Yes. So now you will ask a client to, you will have a client to send some data in the request as a header, a key, a token or a key. We will ask the client to send in the request. If the token is correct, then we will process that request. If the token is not correct, then we don't process that request. So like that, can we write some logic in the request to validate that request object? In the filter, whatever the filter I'm creating, in that filter, do I have the access for complete request object? Whatever the filter I'm creating, for that filter, do we have the complete access for the client request? Yes. You can get body data, you can get the headers data, whatever you want, you can get it. Now, client is sending headers object. Client will send the data in the headers. Suppose I want client to send a token to access my API. So security token, I will ask the client to send in the request. Now, whenever request comes to API gateway, my filter is going to execute because I'm implementing global filter. I'm implementing global filter. So for every request, this filter will be executed. Now, inside this filter, I'm accessing complete request object. Whatever the request client is sending, payload, or it can be a payload, or it can be headers data, it can be bodies data, or whatever the data it is. Complete request data I can access here. So once I have accessed that data from the request, I'm getting headers data. Headers dot key set. So all the headers the client is sending, I can access the keys. Header will be available in the form of key value, right? Headers dot key set. I'm accessing that. Next one, I'm going to iterate this data, guys. I will just print that data. Key set dot for each. Key set dot for each. I just want to print it. Key set dot for each key, and I want to print it. Headers dot get of key. Headers dot get of key. I got the list of keys. From each key, I want to get the value. Headers dot get of key. Okay, guys. Now headers dot get of key is available, which is going to give me list of values. For each key, multiple values can be available. For each key, multiple values can be available. Now I want to print system.out.println key and corresponding values. What is the key? Header key available and corresponding values I want to print. Key and corresponding values I want to print. Okay. Then after here I'm going to forward the request again. Chain.filter exchange. Chain.filter exchange. That request will go and process that request. So like this, we can write a filter in the API gateway. Guys, observe this filter. What is the filter I'm creating? In the API gateway project, I created a pre-filter. This pre-filter implemented by using global filter. Public class, my pre-filter implements global filter. Logger factory dot get logger. I got the logger for the filter. Now inside the filter, as I'm implementing this interface, I need to override a filter method. So for every request, this filter will be executed. For every request, this filter will be executed. Inside this filter, we have a exchange object. Using this exchange object, we can access the complete request. Once we got the request, we can access the headers. Based on the headers, we can get the key set, headers keys. Once you got the keys, then you can get the values of the each key. Once you got this, then return chain.filter of exchange. We will forward that request. We'll forward the request to the next filter. If next filter is not available, then it will go to routing. So when I call chain.filter, so here I have one filter. There can be multiple filters also. Once this filter got executed, I will forward the request to the next filter. If there is no other filter available, then request will go to routing. Okay, guys, fine. So let us start our applications now. Let us see, is that filter getting executed for every request? I'm going to start my service registry once. I'm going to start my service registry. Service registry, go to the browser, localhost colon 8761, localhost colon 8761. Eureka started. Currently, no instances registered with Eureka. Next, admin server. Admin server getting started. Admin server will be running on the port number 1111. Localhost colon 1111. So Spring Boot admin server started. No applications are registered. Let's go and start our Zipkin. So Zipkin we downloaded as a jar file now. Let's open cmd java space -jar space Zipkin jar file. Zipkin we downloaded as a jar. That Zipkin will run on the port number 9411. Zipkin server will be running on the port number 9411. Localhost colon 9411. Yes, Zipkin server started. It is running on the port number 9411. Now let us run our welcome API. Let us run our welcome API. Let us run our welcome API. Welcome API. Check it in the Eureka. Is it registered with Eureka? Yes, it is registered with Eureka. Now run the greet API. Run our greet API. Welcome API is running on the port number 8081. Greet API running on the port number 9091. Running on the port number 9091. Yes, Greet API is running. Welcome API is also running. Finally, let us run our API gateway. I'm running my API gateway. I'm running my API gateway. Okay, refresh. Now, can you see? Welcome API is running on the port number 8081. Greet API is running on the port number 9091. API gateway is running on the port number 3333. Welcome API running on the port number 8081. Greet API running on the port number 9091. API gateway running on the port number 3333. Now, in order to access our applications, we will go for API gateway. Now, when I send a request to /welcome, when I send a request to /welcome with API gateway, API gateway is routing that request to welcome API. So you see, I'm sending a request to the port number 3333 server. Which API running on the port number 3333? API gateway is running on the port number 3333. When I send a request to the API gateway, that API gateway identified the routing. It decided that /welcome should go to welcome API. It sent the request to welcome API. Welcome API gave the response. If I give greet, then it should go to greet API. /greet URL is mapped to greet API. Request will come to API gateway. From the API gateway, it identified the routing pattern. Based on that, it is going to greet API. Greet API having FIN client. So using that FIN client, Greet API communicated with the welcome API. Using this FIN client, Greet API communicated with welcome API. So we got the combined response. We got the combined response. This message is coming from greet. This message is coming from welcome. So we are getting combined response from the greet API and welcome API. Now let me clear my console. Let me send the request again. I send the request. See the console. In the console, is my filter method got executed, guys? Go to the console of the API gateway. Go to the console of API gateway. In the API gateway, can you see my filter got executed? Can you see my filter got executed in the console? I have written a logger. So is that logger executed now? That means, can I say my filter got executed? My filter got executed. Yes, my filter got executed. Using that filter, are we able to understand the headers? What are the headers available in the request? Host header is available. That means to which server you are sending a request. Host header is there. Connection, cache control, upgrade insecure requests, user agent, accept headers, accept encoding, accept language. These all are the headers that we are sending in the request. These all are the headers that we are sending in the request. Are you able to follow this? Are you able to follow this? How to write a filter and how to access request data? Okay, guys, same request. Can I send from the postman? Same request. Can I send from the postman? I'm accessing my API gateway, right? Can I send the same request from the postman? Yes, I want to send a request from the postman. I want to cover one interview question here, guys. So see here. Click on get. I want to send this request. Click on send. Am I able to get the response? Yes, I got the response. When I send a request from the postman, can you observe the headers that are sending in the request? So is there any new header that can you see? Is there any new header that you can see when I send a request from the postman? Can you see postman is sending one postman token in the request? Can you see that in the request there is one header is going with a key called postman token and the value is this token value. Now interviewer will ask this question. How your REST API will understand request is coming from the browser or request is coming from the postman? How our REST API will understand request is coming from the browser or request is coming from the postman? Come on, guys. Based on the header. Based on the header. Now, let me clear this. Same request, let me send from the browser. I send a request from the browser. Observe the console. Is there any token that is going to the API in the from the browser? In the request header, is there any token that is going to the API. So it is a normal request. Normal request means that request may come from browser. That request may come from other application. We don't know. It is just one HTTP request we got for our REST API. REST API will process that request and will send the response. Suppose now clear the console. Now let us send the request from the postman. Send it. Now see the console. There is a token that sent by the postman, extra token added by the postman in the request. So to tell the server that this request is not from the actual application, guys, this request is from the postman for testing purpose. So that is what the information that the postman is giving to the REST API using one token. So now similarly, can we send our own tokens in the request now? Can we send our own token? Key. Now I will send security token. I will write a key security token. My security token will have some secret ID or some secret code will be available. Click on send. Now see the console. Now here can you see, am I able to send one secret token? Am I able to send one security token in the request? Am I able to send one security token in the request? So why we will send these security tokens in the request? Why we will send the security token in the request? To know whether the request is valid or not. We will tell the clients to send the security token in the request. If we receive the security token in the request, then that means it is valid request. Otherwise it is invalid request. So can we do that validation in the filter now if we have a tokens? So now you understand what is the purpose of a filter in the API gateway. Now you got the clarity. What is the purpose of filter in the API gateway? Yeah, tell me. What is the purpose of a filter in the API gateway? What is the purpose of a filter in the API gateway? Come on. What is the purpose of filter in the API gateway? Filters are used to perform some pre-processing and post-processing the request. So by using this global filter, can we access complete request information like headers, body, query parameters, path parameters? Do we have the access for complete request here? Do we have the complete access for the request? Come on, guys. Yes. We can access client sent request information using filter. The request information we can use to validate the request. The request information we can access client sent request information using filter. The request information, the client request information we can use to validate that request. What is the data coming in the request? What are the headers coming? What is the body is coming that we can access? Now, guys, how you will understand? So here, your interviewer may ask this question: how you will understand the request came from application to your application, the request came from other application, or request came from the postman for your REST API? How can you understand? Request came from the other applications, or request came from the postman. How can you identify that? Request came from where? How can you identify that? Based on the token. Based on the token. Who is going to send the token? Who is going to send the token? Postman will add one token. So create below filter in the API gateway. Create below filter in API gateway. It will execute for every request. It will execute for every request. When we send a request to the REST API using Postman, it will send one Postman token in the header. When we send request to REST API using Postman, when we send request to REST API using Postman, it will send Postman token. It will send Postman token in request header. Request header. Using this token, we can differentiate. Request came from other applications or from Postman. Request came from other applications or request came from our Postman. That can be identified by using the Postman token. So when you are giving your API access to the clients, you need to ask the clients to send the security token. Clients will send the security token. So for clients, security tokens will be available. Based on the security token, we can identify the request came from which client, and the request came from Postman or request came from the other applications, or which client sent the request. That can be identified by using this Postman. Clear, guys? The request is from which browser, that also you can check. In the here it is going to display from which browser the request is coming. Header will contain that data. Okay, now from which browser the request is coming, that information also we can identify in the request headers. So this header information we are going to use to identify all the details. Filter is available. We can write our logic inside this API gateway filter. So with this, we are good with this microservices architecture. API gateway will act as front gate for all the APIs. API gateway will act as a front gate for all the APIs available in our application. In the API gateway, we can write the filters and we can write the routing. In the API gateway, we can write the filters and we can write the routing. Okay, guys. Now, filters that are used to process each and every request, you can do validations on the request by using this filter. For every request, that filter is going to execute. Next, routing. Routing will decide which request should go to which backend API. Every request will come to API gateway. API gateway will decide that which request should go to which backend API. For that, routing logic will be available. Next one is service registry. What is service registry? Service registry is also one microservice which is used to register other microservices in our application. Service registry is also a microservice which is used to register other microservices in our application. Okay, guys. Next one, we are having admin server. Admin server is used to monitor and manage our applications at one place. Admin server is used to monitor and manage our applications at one place. Then what is a Jipkin server? Jipkin server is used for distributed log tracing. Jipkin server is used for distributed log tracing. Then next one, Welcome API, Greet API. Welcome API and Greet API are our backend services which contains the business logic. Fee client. Fee client is used for inter-service communication. So with this, we are able to complete our microservices architecture. Perfect. Next one, guys. Next one. What is load balancing in the microservices? There is a concept called load balancing ribbon in the microservices. Okay. So what is load balancing? Load balancing. Load balancing is the process of distributing the load to multiple servers. Load balancing is the process of distributing load to multiple servers. Now here, if I am running my application on one server, for example, here I have taken a server. Inside this server, I am running my application. I have taken a server. Inside the server, I'm running my application. Now, there are so many clients available for our application who are accessing our application on daily basis. Very frequently, our clients will be accessing our application. When a client access our application, all the requests will come to single server. Clients are going to access our application, all the requests will come to single server. When all the requests are coming to single server, then burden will be increased on the server. Okay, so this person is sending a request to the server. So this person is also sending a request to the server. This person also sending a request to the server. Okay, all the people are accessing single server. Application running on single server. Application running with one server. When our application is running with one server, then what will happen? Load will be increased on the server or not? Guys, if we are application running on the single server, burden will be increased on the server or burden will not be increased on the server? Come on, guys. Burden will be increased on the server or burden will not be increased on the server? Burden will be increased on the server. So if a burden increased on the server, then what will happen? If we run our application on the single server, if we run our application on single server, then all the requests will be sent to single server. Burden will be increased on the server. Burden will be increased on the server. If we run our application on single server, then all requests will be sent to single server. Burden will be increased on the server. When burden got increased, request processing will delayed. Request processing gets delayed. Sometimes servers will crash. Sometimes our server might crash due to heavy load. So whenever we run your microservice or any application in the single server, then all the requests will be sent to the single server. If we run our application on single server, then all requests will be sent to single server. If all the requests sent to the single server, then burden will be increased on the server. When burden got increased on the server, request processing gets delayed. Sometimes our server might crash due to heavy load. Then how to overcome these problems? To overcome the above problems, to overcome above problems, to overcome above problems, we will use load balancing. We will use load balancing concept. Understand my point? So we are running our microservices. We are running our microservices. If we run our application on single server, then all requests will be sent to one single server. When all the requests are processing by single server, then burden will be increased on that server. Burden will be increased on that server. When burden got increased, then what will happen? Suppose simple example, sir. If I give you 10 kg bag, can you carry easily? Aram se. If I give you 10 kg bag, can you carry that easily? Will it be difficult for you to carry 10 kg rice bag? Any bag with 10 kg weight? Come on, respond. If I give you 10 kg weight, will it be difficult for you to carry that? No. You can easily carry. If I give 100 kg bag, can you carry that? If I give 100 kg weight, can you carry that? No. It will become difficult because the load is increased, the weight increased, the burden got increased. The load increased, the weight increased, the burden got increased for you. Same concept applicable for servers also. Same concept is applicable for servers also. When less number of requests are coming, servers can process that quickly. When less number of requests are coming, servers can process that quickly. If more number of requests are coming, then burden will be increased on the servers. When burden increased on the server, what will happen? So many requests are coming to a single server, then request processing may take time, responses will be delayed, waiting time will be more for the user to get the response, out of memory issues will come, and servers might get crash also when we go for this concept. When we go for this concept, are you able to understand my point? Are you able to understand my point? Come on. Okay, guys. If we run our application on single server, then all requests will be sent to the one server. When all the requests sent to one server, burden will be increased on the server. When burden got increased, request processing gets delayed. Sometimes our server might crash due to heavy load. To overcome these problems, we will use load balancing. What is the concept of load balancing? Load balancing is the process of distributing load to multiple servers. Okay, distributing the load to multiple servers. Sir, how can we do that? How can we do that? Instead of running our application in one server, we are going to run our application in multiple servers. We are going to run our application in multiple servers. Server 1, server 2, server 3. Okay. So server 1, same application will be running in multiple servers. Now, who is responsible to distribute the load now? Requests are coming to our application. 100 requests came to our application now. How these requests will be distributed? Who will take the responsibility to distribute the requests? That's where load balancer comes into picture. So there is a concept called load balancer. Load balancer is also called as LBR. LBR is nothing but load balancer. All the servers which are available for our application, like a server 1, server 2, server 10, it can be multiple. It can be multiple. You can take 10 servers also. Now this load balancer will be connected to all these servers. Load balancer will be connected to all these servers. Whenever requests are coming to from the people, whenever the requests are coming from the people, those requests will go to our load balancer. Okay guys, now, so whenever we have a single server, that single server is responsible to handle all the load. All the incoming requests should be handled by single server in the first approach. When single server is handling all the requests, then burden will be increased. Okay, so to reduce that burden, application with a load balancer. Application with a load balancer. Application with load balancer. Application running with one server, application running with multiple servers. So what is the drawback if you go for first approach, and what is the advantage if you go for second approach? Guys, can you tell me what is the drawback if you go for first approach, and what is the advantage you are getting when you go for second approach? Come on. What is the drawback if you go with first approach, and what is the advantage you are going to get with the second approach? Make it fast, quick. In the first approach, single server is executing. In the first approach, single server is executing to process our all the requests. Okay. If 1000 request comes, one server is responsible to handle that. If 1000 requests comes, one server is responsible to handle that. Burden will be increased on the server. Burden will be increased on the server if you run your application on the single server. So to reduce that burden, we are going to run our application on multiple servers with a concept called load balancer. So what is this load balancer? Our application will be deployed into multiple servers. Same application, same jar file or same war file will be deployed to multiple servers. Those servers will be connected to load balancer. Now when clients send the request to the load balancer will distribute the load to server 1, server 2, server 3 in the round robin fashion. First request will go to first server, second request will go to second server, third request will go to third server. Here, this load balancer will distribute the load. Load balancer will distribute the load based on round robin technique. What is the meaning of round robin technique, guys? What is the meaning of round robin technique? Can you guys tell me? What is the meaning of round robin technique? Come on, guys. What is the meaning of round robin technique? Come on. What is the meaning of round robin technique? One after other, one after other. First request will go to first server, second request will go to second server, third request will go to third server, again it will come to first server. So it is a cyclic process. It is a cyclic process how the request will be distributed. First request will go to first server, second request will go to second server, third request will go to third server. That is called round robin technique. So if you run your application with one server, then burden will be increased on that server. If you run your application with one server, then burden will be increased. So to reduce that burden, we are going to run our application in multiple servers. So how we are going to send the request to those servers? We will not send the request to the servers directly. We will be sending the request to load balancer. That load balancer is responsible to distribute the request to multiple servers so that performance of the application will be good, burden will be reduced on the server, applications will be executed quickly. applications will be executed quickly. Are you clear with my point? Are you clear with my point now? Are you clear with my point now? Okay, that's fine. Now I want to run my application with load balancing. I want to run my application with load balancing. Okay. Yes. Guys, here already in the last session, we have deployed our applications. Whatever the microservices we have, we are running those microservices, right? We are running those microservices. Now, whatever the welcome API I have, guys, see here, whatever the welcome API I have, for the welcome API, more number of requests are coming. Now see, I want to run the welcome API in another server. I want to run the welcome API in another server. So can I run welcome API as two instances like this? So one box means one instance. Second box means second instance. That means I want to run the welcome API in the two instances, and I want to show you that load balancing. Is it clear? Is it clear? Can we run the welcome API in another instance, and can we show the load balancing now? Right? So already welcome API is running with 8081. Now let us see. I'm going to run the welcome API with a different port number, guys. I can't run with the same port number. Run as run configuration. Port number already there in the YML file, right? 8081. Now I want to run the welcome API with a different port number. I will pass the port number dynamically. Server.port is equal to 8082. Apply and run. Now I'm running the welcome API. First, see here how many instances available for welcome API. One instance is available for the welcome API, and this is the URL. Now I am running one more instance for the welcome API. Now can you see welcome API having two instances? Instance 1 is running with 8081, instance 2 running with 8082. So with this, can I say that my welcome API running in two servers, same code is running in two servers? How I able to run the application with two servers? Right click on the welcome API, run as. If you directly run it, it will take the default port number, which I have given in the YML file. What is the port number I have given in the YML? 8081 is the port I have given in the YML. So with 8081, already one server is running. Can I run the second server also with the same port number? Can I run the second server also with the same port number? No. Now I want to give the different port number. How can I give the different port number? Can I give the port number in the runtime? Right click, run as, run configuration. Can I supply the port number as a VM argument? Yes. Currently see how many servers running for welcome API? Welcome API running as two instances. What is the meaning of two instances? Server 1, server 2. In 8081 server, welcome API is running. In 8082 server, welcome API is running. Let me run this in the another server also. Observe carefully how I am going to run it. Welcome API, right click, run as, run configuration. Here we have a arguments option. Select this welcome API. Here, Spring Boot application welcome API. Observe carefully. Right click on the project which you want to run with a different port. Right click, run as, run configuration. Select the welcome API. Go to arguments. Give the argument. -D represents the system argument. I am passing these arguments to my JVM. If you give program arguments, these are command line arguments. For the main method, I want to pass arguments to the JVM. For that, I will use -D. -D server port is equal to 8083. Apply and run. Now I am running welcome API in another server. Now I am running welcome API in another server. Now observe carefully. See this. Now, can you see welcome API is running in three servers now? 8081 server, 8082 server, 8083 server. Are we able to run welcome API in 3 servers? Why I am running welcome API in 3 servers? Same API, welcome API only. Why I am running in the 3 servers? Why I am running in 3 servers now? For load balancing. So you understood how I started the welcome API? Okay, now when I access this welcome API using this greet, request is sent, response is coming. Welcome to Ashok IT, this response coming from the welcome API. But how to understand this welcome API is running in 3 servers, which is server has given this response? So by looking at the response, can you understand this welcome to Ashok IT message came from which server? There are 3 servers available for welcome API. Server 1 is available, server 2 is available, server 3 is available. Can you understand? Can you understand from which server we got that response? No. Let me make some small change in the code, guys, so that I will tell you from which server we got that response. I will print the port number. I will print the port number. Private environment, Spring Core environment, env. Let me use some auto wiring. I will get some port number. On which port number our server is running, I want to get that port number. Welcome REST controller, env dot get property server dot local server dot port. I want to get that port. From which property we are getting this? Okay. Welcome to Ashok IT. Welcome to Ashok IT message. I will specify port. Okay. From which port number, from which server we got the response? I'm injecting in. This is just for our understanding purpose, guys. In the real time, we don't print the port numbers anywhere. I just want to show you that load balancing is working. So here I'm going to use environment object. It is a predefined object that we are injecting. Okay, org.springframework.core.env.environment. I have injected environment object by using auto wiring. Using that environment object, I have taken get property, env.get property, server.port I have taken, which will give the port number in which server this application is executing. It will give that port number for us. I'm just printing welcome to Ashok IT message coming from which is server, that port number. Based on the port number, we can understand that. Okay, so my application is getting restarted. Let us see here. Welcome API. What is the status now? Down 3. Why down? They are restarting. The welcome API is down. The remaining APIs are up. Down means they are getting restarted. Now can you see the status up again? They are restarted or not? They're able to restart or not? Yes. Now let's make a request to the /greet. When I send a request to /greet, we are going to get the response of only greet API, or we will get the response from the welcome API also. When I send a request to /greet, the response comes from only greet API. The response comes from the welcome API also. Welcome also. Greet API is running in how many servers now? Greet API running in how many servers? How many instances available for Greet API? There is only one instance available for Greet API. In the welcome API, how many instances available for the welcome API? Welcome API running in one server or welcome API running in 3 servers now? Welcome API running in the 3 servers. Okay, send the request. From which server I got the response? Welcome to Ashok IT, which server? 8083. See here, welcome API running in 8081, 8082, 8083. So first time I got the response from 8083. Send the request again. Am I getting the response from second server? Send the request. Am I getting the response from first server? Send the request. Third server, second server, first server. Second, third server, second server, first server. Third server, second server, first server. third server, second server, first server. Are we able to do the load balancing? Are we able to do the load balancing? Is it working in the round robin mechanism? Is it working in the round robin mechanism? So now, what is the advantage with this round robin technique now? What is the advantage with this round robin technique? All the requests are going to one server. The requests are going to multiple servers. Multiple servers, the load is distributed. I am sending a request to Greet API. Greet API having a FIAN client. FIAN client is talking to Welcome API. For Welcome API, one URL is available. There are 3 URLs available, 3 URLs available. FIAN client is accessing Welcome API in the round robin fashion. FIAN client accessing the Welcome API in the round robin fashion. That's why when I send a request to Greet message coming, welcome message coming from all the 3 servers in the round robin fashion. Here 8081, 8083, 8082. What is this 8081, 8082, 8083? Port numbers of the servers. So the requests are distributed to 3 servers in the round robin fashion. So that is called load balancing in the microservices. That is called load balancing in the microservices. Able to understand how the load balancing implemented? I'm running my service in the 3 servers. I'm running my service in the 3 servers. Welcome API is running in the 3 servers. Instances currently registered with Eureka. So there are 3 servers available for Welcome API. So that is called load balancing. Are you able to understand the load balancing with the 3 servers? 3 instances available. 3 instances available. Okay, so please practice this before coming to tomorrow's session. So tomorrow I will talk about internals of that load balancing, how it is distributing the load with round robin technique, which concept it is using internally, what is the ribbon in the load balancing. So that we are going to discuss in the tomorrow session. So please practice this before coming to tomorrow's class. Thank you guys.